Okay, we are live now. So what I'm doing is basically I created one presentation where I'm clubbing both of them together, and I'm just putting the topics which are important and which are in the textbook. Okay, so I started here, started data structure. They might ask what data structure is, so I put that there, and then whatever topics are there, I put that in the classification, so it's organized. Then types of data structure, arrays, single. Okay, let me remove that. Okay, then structures, then lists, linked list, types of linked list, circular linked list, then stack, operation and stack. I've assigned some other things to you. Like for example, what, how will we correct this statement? For stack, it was like whenever an element is added, it's added on the top of the stack, and elements get deleted from the top of the stack. So how can you change this for Q?
Elements are removed from the front and they're added at the rear.
Okay, so that's the top only, right? Or it will not be called like top, it will be called front.
Yeah, it's called front.
So insertion and deletion are done from two different ends, right?
Yeah, in a queue.
Hmm?
Yes, in a queue, right? You're not
Yeah.
sharing your screen.
Oh shit. Okay. But you still answered well. Thanks. Okay, this is I was correcting actually. So now that's done. So I'll check mark that. And done that. Okay. Fine. So yeah, data structure classification, arrays, multidimensional structure, list, circly, singly, stack, queue. I'd like you to write on the operations. This is important. Like we put it for on stack, just in one-liners. Similarly, put them for queue over here. Okay. Then we do the trees. So I'm just going to copy paste. What else is there? So trees, advanced trees, BST. Trees are discussing binary search trees. So I think we should put topics related to trees. So might ask us about the binary tree and general trees. I'll put that there also. Of course, we don't have to remember all the points, but at least a few. Then in advanced trees, yeah. So I guess they're just covering the binary search tree. So binary search tree, it's done. BSD. Then they have graphs, vertices, edges. It's always. Oh, they have algorithms also. Oh, shit. So now next topic will be graphs. Yeah, graphs. Collection of vertices. Okay, I'll format it later. And then the Shikshra and Kruskal's. I think we'll just do those two. The Shiks. So spelling. The Shikshra. And then Kruskal's. Okay. So I'll do the rest of the things later. It's like almost done. Um, which is basically all sort of searching, sorting algorithms. I'll put all of that there. But now let's start with the database management queries. Um, so SQL board. We'll start with the practice here. Okay, list all the Canadian cities and their populations. We'll spend around 15 minutes on this one. Then we'll do the theory part for another 15-20 minutes, and then we'll get back to uh, the programming. So list all the candidate cities and their populations. Select. Uh, candidate city. So city and population. Population from table name is not. Have I moved a very? Okay, yeah, this is fine. North American cities. So why is this not checked? Okay, all Canadian cities where country equals Canada. What are all the cities by latitude? I think we've gone too far. Like we've gone very advanced one. Let's start with the basics. Find the title of each film. Find the director of each film. Select director of each film. Any title also then from movies. Or there's just one director, I guess. Find the title and director of each film. Okay. Title and year. Okay. Find all the information about each film. Select all. Continue. Uh, Query with constraints with the where condition equal to between, not between, in, not in. Okay, let's see. Find the movie with a row ID of 6. Select title from movies where ID equals 6. Okay. Find movies released in year between so and so. Okay. Select title from movies where year um, is between 2000 and 2010 is greater than 2000, greater than equal to, I think, 2000, and year less than equal to 2010. Yep. Find movies not released in the years between so and so. So select title from movies where year is not between, which means year should be less than 2000 and year should be greater than 2010, not between. The heck?
Year is greater than 2000.
No, they're saying that not released in these years. So what I'm trying to do is that I'm saying year should be less than 2000 because there you don't want
Oh,
between these
okay.
things. Why it's not working? Mm,
Or
ah,
it should be or.
yeah, you're right. Good catch. Find first. So may I ask, since how many years are you programming?
Um, around 10 years.
10 years.
I learned when I was a kid.
Wow, no doubt. So wondering how fast you pick up things. For me, it's been like, I think it's been almost 4 to 5 years.
Mm.
Yeah,
I haven't been doing seriously, just like a hobby.
but still 10 years, long time. Wow. Okay, cool. Uh, so have you not thought of like working for a company or something, or do you think that you just be teaching?
Yes, I'm going to after I finish PGDC.
Do you know what is after PG this year? Like MCA for 2 years?
No, I'm not doing MCA. I'm thinking of doing an online MSCS from Georgia Tech.
Okay. MSCS.
Yeah, search for OMSCS. Yeah, or that.
This one.
Yeah.
What does it teach? Like, what's the subjects?
Um, they have various subjects. I'm thinking of doing the data science one.
Okay, so is it going to be only that, or will it be covering more stuff besides data science?
It'll be covering like most computer science topics, but my specialization would be in data science.
Okay. And why did you choose this one in specific? Like, what's the why this and why not others? Like, what's the benefit of this one?
This one was the most popular one, and um there were a lot of good reviews.
Okay. And like, how many years is this?
2 years.
2 years. Okay. And you can do it after doing PGDC, right? You can't do it before that.
Yeah, because they require a 4 year bachelor's degree
Okay.
or an
So, but if
equivalent.
or if you've done PGDC, then it's fine, correct?
Yeah,
Okay. Okay. Right. I'll check it out.
so it's exactly the same as the on campus degree,
Okay. Okay, but online.
only
This is
online.
online.
Yeah.
Okay. But how about the exams? Like, I'm sure they will have centers in India.
I'm not sure how they do the exams. I think they're online.
Okay. Okay. Cool. I'll check it out. Uh, Find the first five Pixar movies and their release year. First five. So title from movies. Um, this is going to be limit five. Okay. When writing where clause containing text SQL, suppose a number of useful operators. So I'm doing this today. Tomorrow you can do this. Okay, like from the start.
Okay.
Uh, when writing where clause with columns containing text data, SQL supports a number of useful operators to do things like case insensitives, string comparison, wildcard pattern matching. We show a few common text data specifics. So equals, not equal to, less than equal to, like, case insensitive. So like is case insensitive, not like again case insensitive. You have to put it in quotes. Percentage is used anywhere in a string to match a sequence of zero or more characters. This matches this. Okay. So basically, in that word, that thing needs to be there. Before, after, doesn't matter where. Okay. Used anywhere in the string to match a single character, only like and not like a but not an. Okay. So which means an should be followed by some character. In string exists in the list. Okay. So there will be a list and not in. Okay. Let's try. Find all the Toy Story movies. Okay, so select title from movies where title like toy percentage. Yeah. Next. Find all the movies directed by John Lasseter. Select title from movies. I love this tool. It's really, really handy. Where director equals John Lasseter. Okay. Find all the movies and director not directed by John Lasseter. Select title um, from movies where director equal not equal to John Lasseter. Notice that I could have just replaced the previous one with not equal to, but I'm repeating that because I want to get it in practice. So we don't usually use these database like in our daily work. We don't really do that because WordPress has its own functions and helper functions which does all of these things for us. So yeah, I'm just doing the practice. Find all the movies. Oh, sorry, I find all the wall movies. So there's a wild card there. To select title from movies where title like, so we have to do wall like that. Um, yeah, cool. Let's recap that. So percentage match a sequence of zero or more characters only with like and not like. It's understood. Used anywhere in string to match a single character, not like. So this is just for single character, and this is for like if you want to do more than one character. So that's a wild card there. Cool. Then filtering and sorting query results. Even though the data is in database may be unique, the results of any particular query may not be. Take our movies table for example. Many different movies can be released the same year. In such case, SQL provides convenient way to discard rows that have duplicate columns value by using distinct keyword. Select distinct. So we're not going to get duplicated records. Okay, now distinct keyword will blindly remove the duplicate rows. We will learn in future lessons how to discard duplicate based on specific column using group by. Group by is important. I think they might ask us. So what is group by used for? Grouping multiple columns.
For grouping rows that have the same column value.
Grouping rows that have the same column value. Okay. Unlike a neatly ordered table in last field, most data in the real database are not particular column order. Hence, as a result, it will be difficult to read through and understand the result of the various size of the table increases. So to help with that, we use order by. Order by specified is sorted alphanumerically based on specified column value. In some databases, you can also Specify a collation to better sort data containing international text. Another clause commonly used is order by clause are limit offset clauses, which are useful. Okay, limit will reduce the number of rows to return. An optional offset will specifically specify where to begin. Okay, let's try that. Can we do it like a 4 o'clock, 4 to 6:30 or something tomorrow? Or will it be too early?
Yes.
Yeah, because it's a weekend, right? So I think we'll spend some more time. I
Okay.
have kind of an intuition that most probably next week we're going to see something from RC Pune. Most of the places already happening. Cool. List all the directors of Pixar movies alphabetically without duplicates. So select distinct title from movies where no order by sending. Uh, some of the alphabetically without duplicates. Oh, directors, not title. कुछ दो साथ में खाने के लिए कुछ है कि नहीं हाँ क्या है बिस्किट ला कर let me see director no such column order by director. Yeah, you have to put the specify the one that you want to do the ascending. List the last four Pixar movies released, ordered from most recent to least. Last four movies released. Select title from movies. Order by year. Recently means we have to do descending. And what else? Last four means limit 4. Sorted alphabetically, first 5. Order by title, sending. First 5, limit 5. Next 5 Pixar movies sorted alphabetically. Select title from movies. Order by title, sending. Sorted alphabetically. Next 5. So offset 4. No, offset 5. And then I have to give limit also, I guess. Cool. I think we'll stop the query thingy here. We'll move to the theory part. Can you make a note of this link and give it to me tomorrow? Because you will be starting from here.
Okay.
I'll share that in chat. They might ask us what is the data structure. So yeah, please read this.
Data structure is a way to store and organize data so that it can be used efficiently.
Okay, carry on.
Classification of data structure, um, linear data structure, and non-linear data structure. A
Mm-hmm.
linear data structure can be a static or dynamic data structure.
Mm-hmm.
Um, Static data structures have arrays. Dynamic data structures are queues, stacks, linked lists. Nonlinear data structures are trees or graphs.
Okay. So data structure, a way of storing and organizing data, um, so they can be used efficiently. Linear means that uh, it's in unidirectional, not like circular. Um, so what is the meaning of linear data structure? Do you know?
Uh, it's stored in a sequence.
Okay. Okay. And a non-linear is not stored in sequence like tree and graph. And static, I think the size is fixed in static. Dynamic sizes can be variable. In a queue and stack, we can put elements, remove elements, grow and shrink its size. Let's see. We go on.
There are two types of data structures, linear and nonlinear. Linear data structure. Data
Sorry
elements
to
are
interrupt.
arranged
The pronunciation of this is linear, not linear. Okay.
linear.
Yeah, short. So the I is short. It's we don't stretch li. It's linear. Okay.
Linear data structure. Data elements are arranged sequentially or linearly where each element is attached to its previous and next adjacent elements.
Mhm.
Examples of linear data structures are arrays, stacks, queues, linked lists, etc. They are of
Yeah.
two types, static and dynamic.
Mhm.
Static data structure has a fixed memory size. It is easier to access the elements in a static data structure. Example of this data structure is an array. Dynamic
Yeah.
data structure, the size is not fixed. It can be randomly updated during the runtime, which may be considered efficient concerning the memory space complexity of the code. Examples of this data structure are queue, stack, etc.
Okay.
Nonlinear data structure. Data elements are not placed sequentially or linearly. We can't traverse all the elements in a single run only. Examples of nonlinear data structures are trees and graphs.
Mhm. Okay.
Arrays. Array is an object which contains elements of a similar data type. Additionally, the elements of an array are stored in a contiguous memory location. We can store only the fixed size of elements in the array. It doesn't grow its size at runtime. Array is a list of variables of similar same data type.
Yeah. I think there's no need of putting this again. Fine. So yeah, you declared like that int. Uh, okay. I think this is Java, right? This is the Java definition, the declaration of an array. I think I should put C also over here to avoid confusion. Array declaration and initialization in C programming. Example. Yep, like that. Java and then C. I should put it down. That's better. So now you're seeing both. You're seeing Java example of declaration and you're seeing C programming also. You'll not get confused. So I think this bracket just moves here in C. So the bracket is associated with the variable name in C, and this square bracket is associated with the type in Java. That's the difference. Are there any other language I'm missing? Yeah, I don't have to worry about Python because Python is nowhere in this semester. It's fine. Moving on. Please carry on.
Multidimensional array is an array of arrays that uses more than one index to access the array elements.
Okay. Let's give an example of both. So I think this is Java example. Let's do a C also. Here is multidimensional example. Do they have multi? If it's 3 by 3, how come they put everything in one? Yeah, missed the one. Correct. Uh, so I think they're initializing, but they're not adding the value in Java. Here it is, like that. It's very similar, I think, except the fact that why they've colored it. Yeah, how do I remove the color now? It's because of that. 2D, 2D, 3D. Are there three-dimensional array in C programming also?
Yes, I think you can
Okay.
have any number of dimensions.
So usually, like in C, there's rows and there's columns. So what happens in the three-dimensional array? What is the third thing then?
I don't know.
Not explaining. Not explaining. Okay, so 2D is three rows and three columns. What happens when we add it becomes a 3D array? First dimension represents the block size, total number of 2D arrays. Second dimension is the rows, and third dimension is the columns of the 2D array. Number of blocks is 2, rows is 3. See, that's how it's. So we learned something today. Even I always used to get confused about the multi-dimensional one. So this is very interesting. What they're saying is that the first thing that you see here is the number of blocks. So in this, there are three blocks, one, two, three. Uh, in this example, there are two blocks, one and two, right? And these are your rows and columns, the next ones. Now I'm wondering what happens in the four-dimensional array.
Then you have a block of blocks.
Block of blocks. Let me see if they have some example. I didn't. Oh, I put 3D, so of course they won't show that. But that's interesting. See if by changing the URL does anything. No, they don't. Anyways, I won't. You won't spend too much time on that. At least you got some idea. So, did we get the screenshot? Let me see. No, I didn't get the screenshot yet. Why did I not take a screenshot? Okay, cool. Okay, so that's your multidimensional. Now we go to structures. Oh shit, I didn't drink the tea. It became cold. Okay, so go on.
A structure is a collection of elements of one or more data types.
Okay. So collection of elements is something you have to remember, and of course there are more than one data types. When we want to construct one data type that combines multiple data types, I think that's when we create structure. For example, in this case for node.
The
We
value
could,
of each element
yeah, go on.
the value of each element of the structure is referred to its corresponding identifier coupled with the variable name of the structure.
Okay.
Linked
Finishing so
lists.
fast, right? It's finishing.
What?
The lab thing is finished. Lab topics are finishing so fast.
Yeah. A structure is a collection of elements of one or more. Wait.
Wait, I think I kind of need not delete this. This is it.
The linked list is a chain of structures in which each structure consists of data as well as pointer which stores the address or link of the next logical structure in the list.
Okay.
A linked list is a data structure used to maintain a dynamic series of data. Think of a linked list as a line of bogies of a train where each bogie is connected on to the next bogie. If you know where the first bogie is, you can follow its link to the next one. By following links, you can find any bogie of the train. When you get to a bogie that isn't holding or linked on to another bogie, you know you are at the end.
Okay. So link is a chain of structures in which each structure consists of a data and a pointer. Let's kind of break this chain of structure. Each structure consists of data and a pointer. Pointer, which in the bracket, which stores the address or link of the next logical structure in the list. I think I want to call it like node. Should we call it as node instead of a structure?
Yeah, we can, I guess.
Nodes. Okay. I want to just keep it simple. I think we're just unnecessarily complicating it. A linear data structure, not stored in contiguous memory location. Okay. Yeah, this is better. We may want to put it like a linear data structure. Now it becomes full definition that consists of a linear data structure that consists of nodes. Each node contains a data field and a reference. Was it pointer in the? Was it calling it a pointer in the previous text? Yeah, where each node consists a data field and a pointer, which is a reference link to the next one. Yeah, cool, cool. Move on. Okay.
Types of linked lists. Single
Mhm.
linked list is the simplest type of linked list in which every node contains some data and a pointer to the next node of the same data type.
Okay.
The node contains a pointer to the next node means that the node stores the address of the next node in the sequence.
Did you say nod?
No, I said node.
Okay, cool. Glad you nodded on that.
A single linked list allows the traversal of data only in one way.
Okay.
Doubly linked list or a two-way linked list is a more complex type of linked list which contains a pointer to the next as well as the previous node in the sequence. Therefore, it contains three parts: data, a pointer to the next node, and a pointer to the previous node. This would enable us to traverse the list in the backward direction as well. Circular linked list is a variation of linked list in which the first element points to the last element and the last element points to the first element. Both singly linked list and doubly linked list can be made into a circular linked list.
Okay.
Singly
So,
linked list as circular. In singly linked list, the next pointer of the last node points to the first node.
mhm.
Doubly linked list as circular. In doubly linked list, the next pointer of the last node points to the first node, and the previous pointer of the first node points to the last node, making the circular in both directions.
So tomorrow we're gonna start with the difficult topics like the algorithms, your quick sort, merge sort, and all of those things. Because I think those are the ones that are more common. Of course, we know these linked list and circle and all of those things. So yeah, we'll breeze through them. We won't do them every day. Uh, like we'll do these topics that we're covering today, like every alternate day or after 2 days or something. But yeah. Algorithm part and sorting and those things we look at every day so it's fresh in our head. Okay.
A stack is a linear data structure that follows the last in, first out principle. Stack has one end, whereas the queue has two ends, front and rear. It contains only one pointer pointing to the topmost element of the stack. Whenever an element is added in the stack, it is added on the top of the stack, and the element can be deleted only from the top of the stack. In other words, a stack can be defined as a container in which insertion and deletion can be done from the one end, known as the top of the stack.
No need to go through that. I'll go through this. So we have push, pop, push to push the element. Pop is to remove an element from the top. Is empty to check if it's empty or not is full as it describes. Peek is to retrieve or fetch the first element in the stack. Count returns the total number of elements in the stack. Change changes the elements at a given position. And display prints all the elements in the stack. Queues also linear data structure. Unlike stack, which was uh, LIFO, last in first out. This is FIFO, which is first in first out principle. So whichever element is added first will be the one to get removed first, just like a queue. So it has two ends, front and rear. Whenever element is added in the stack, added the front of the queue, and the element can be deleted only from the rear. In other words, stack can be defined as a container in which insertion deletion can be done from two different ends. Are done, not can be done. Queue can be implemented using arrays of pointers. The order of deletion of elements from the queue will be exactly the same as the order of addition of the elements in the queue. No, wait. You can draw an analogy of a queue data structure to the people standing in the queue for entering a bus. Operation, so you'll put that, right, Sumaya?
Yes.
Okay. DQ is a special form of a queue in which addition and deletion elements is possible to be done in the front as well as the rear. So concept of FIFO does not hold here. Just spend some time, like whenever you get time, and see like what's this DQ thing all about. I know it was there in the exam also. So DQ is not really the operation we're talking about here. DQ is like a special form of queues. Just read more and let me know.
Okay.
Uh, trees. Tree is one of the data structure that represents hierarchical data. A tree data structure is defined as collection of objects or entities known as nodes that are linked together to represent or simulate hierarchy. A tree data structure is non-linear data structure because it does not store a sequential manner. Uh, it is a hierarchical structure as elements in a tree are arranged in multiple levels. In a tree, topmost element is known as root node. Each node contains some data, and data could be of any data type. In the above tree structure, node contains the name of the employees, so the type of data would be string. Each node contains some data and link or reference to other nodes that can be called children. The nodes that do not have children are called leaf nodes. General tree, each node can have many child nodes. Binary tree, each node can have maximum two nodes. General tree, subtree of a general tree do not hold ordered property. Subtree of a binary tree holds ordered property. General tree cannot be empty. Uh, Binary tree can be empty. General tree, there is no limitation on the degree of the node. In binary tree, there's a limitation on the degree of node because nodes in binary tree can't have more than two child nodes. In general tree, there is either a zero subtree or many subtree. In binary tree, there are mainly two subtrees, left and right. Binary search tree is a binary tree that is either empty or a node containing the key value left child and right child. The non-empty BST satisfies the following condition. The key in the left child of a node, if exists, is less than the key in its parent, and the key in the right child of the node is greater than the key in its parent node. The left and the right subtrees of the root are again binary search trees. Okay. This is your binary search tree. A tree is balanced if for all the nodes, difference between the height of the left node and the right subtree is not greater than 1. These are nodes, these are leaves. So the left one will be smaller than its parent, and the right one will be greater than its parent. And the same rule applies as we traverse through the tree towards the bottom. Graphs. Graph is a collection of vertices and edges. The set of vertices is always non-empty. Edges represent the ordered or unordered pair of vertices which are directly connected with each other. If pair of vertices are unordered, it means that an edge indicates that V1 is directly connected to V2 and vice versa. If pair of vertices are ordered, it means that edge V1 V2 indicates that V1 is directly connected to V2. V2 is directly connected to V1 only if the edge V1 is present in the list of the edges. Okay, moving on. So basically, key thing, collection of vertices and edges. It's more like that. Okay. The Shikstra's algorithm will do tomorrow. Don't have that much time. Minimum cost span entry. Algorithm will do tomorrow. Yeah, good. We covered that. Let's plan for tomorrow now since we only have 6 minutes. Uh, Tomorrow we can do some program. What have we done last time? That was the insertion sort, right? Let's get this PR merged quickly, whichever has been done. This is working fine now, right? After you merge, you tested it.
Yeah.
Okay. I would say let's review this before we merge. I'm assigning it to you, just review it. If there are any comments, anything needs to be changed, put it there. Okay. Do you get
Okay.
notification when it's assigned to you for review?
Yeah.
Okay. What else is there? If you addressed all this feedback,
Yeah.
okay. Okay. So this I already, yeah, this I put it for review. So please take a look at this as well. So there are two PRs for you to review. These two. Okay, for tomorrow, let's see. We were on the link list. Yeah, we did that. So tomorrow we're going to do stack, which is this one. Cool. We'll probably start our day with some program to make a change. Spend like 15-20 minutes and then move on to the other stuff. Okay, so at least we have something written because today we couldn't write anything.
Okay.
All right, so I'll catch up with you tomorrow at 4. Okay,
Yeah.
okay then. Bye bye. Good night.
Bye.